All right. Number one, what should we do? Differentiate. When in doubt, differentiate. If you have an equation, when you differentiate, what do you get? dy dt equals what? Cool, 6x dx dt. Is there any questions with our differentiation there with respect to time? Then plug stuff in. Do we know dy dt? Yeah, 7. All right, cool. Do we know x? 3. We want to find? That'll stay dx dt. Can we solve that equation? All right. Ta-da. So multiply, divide, be done. So number one, very straightforward, generic x, y stuff. Number two is similar, a little more nuanced, not a lot. So for number two, you've got your x times y squared equals 8. And then start with differentiating that, see what you know. If you need to find out any more information, come back to x times y squared equals 8 and find that out. So go ahead and try number two. By the way, number two, when you differentiate, what will we need? Product A, so don't forget that. Yes. Yep. Okay. So you will differentiate. You will also use the original equation to find out x. And then once you know x, and you already know y, and you already know dx dt, then you can find out dy dt. Hi, Kaza. Hey, Sabi, I'm trying to mess with the camera here.
Yeah, I was about to say, I can't see anything.
Yeah, I'm going to present in the Google Meet the worksheet that I'm presenting here in class so that you can see that in just directly in the Google Meet. And then, so you can see that, and then I'll have the camera over on the board for going over it. So I'm just going to mess with the camera here, and you can look at the other thing that I'm presenting so you can see what the problems are, and then switch over to the camera when it's time to go over it. So. Alright, so when we differentiate, what do we get? Alright, so dx dt times y squared. So that's d first times original second. And then what? So x times 2y dy dt equals 0. Alright? And then Lucas pointed out we need to find out x. To find that out, you come back over to the original equation, and what can you put in here? Y. So what do you know about y? 2. So once you do that, what do you find out about x? It's also 2. So then now you can come over here and fill in everything that we know. So both what was given and what we found out. So this is one of those where there's some back and forth between the original equation and the derivative equation. So it's not like the first one where you just get the derivative, information dump, and you're done. Here you get the derivative, you go back to the original, get one more piece of information, and then you come over here and information dump. So dx dt, do we know it? Yeah? Okay, so that's 4. Y, do we know it? 2. X, do we know it? We do now, it's 2. Y, it is 2. And we want to find out dy dt. So just go now in and say, hey, we know what dx dt is. We know what y is. That was given. We know what x is. We just found it. We know that 2 is 2. We know that y is 2. That was given. And now you can solve that. Any questions with derivative, finding out x, or plugging stuff into the derivative? What do you end up with for dy dt? -2? Okay. So any general comments, questions about stuff like 1 and 2, where it's just, there's no meaning behind the x's and y's, it's just x's and y's, and can you deal with the kind of differentiation with respect to times? All right. So the third one there is a ladder problem. Go ahead, try to draw your picture, do the ladder problem. I'll scroll here so you guys can see it a little better. Hi, Leah. We're doing whiteboards. I mean, not actual, unless you want a real whiteboard, I'll get you one, but I don't think this really lends itself to whiteboards because I think it takes up too much space. So just try these in your notes. Say again? Yeah, it's not going to be falling for very long. Yeah. And then once you know why, you come back in here. And all the stuff. No. Is positive. Moving away from the house, so that base gets big. Whatever that makes. What's wrong with the clock? Oh, it's got like
really fast.
so my clock has 8. You guys, does anybody not know what AFib is? Some to look forward to for some of you in your old age. Your heart goes haywire. Sometimes your heart beats faster. And it kind of like gets stuck, like your heart is stuttering. My dad's got it, so. I know all about AFib. It killed my grandma. My dad has it now.
Oh, atrial fibrillation.
Yeah, atrial fibrillation. The alternative is ventricular fibrillation, which is much worse. That'll kill you.
I remember my grandma that's all.
Yeah, it can give you strokes, potentially. It's dangerous. And a stroke is just a heart attack in the brain. You okay? Getting old sucks, but it's got to be the alternative. The alternative is dying. Anyway. So you want to see? Like, all we got to do is talk about morbid stuff, and now you're begging to go back to math, right? No, tell me more about how your parents and grandparents are going to die. So, and eventually, possibly me. So, I don't know. Maybe they'll have a cure for AFib by then. All right, so you got your picture. This is going out. What do you guys want to call this thing? An X. All right. Some people call it X. Some people call it B. Doesn't matter. What do you want to call this thing? What do you want to call this thing? Or just 15. Which of these quantities does never change? C, X, or Y? C never changes, right? So only X and Y change. So they're really variables. And then you know this is going out from the house at what rate? 5 feet per second. So what do we want to call that? A dx dt or a dB dt, depending on how you label stuff. And the goal is to find out how fast this is falling, right? So what do you want to call that? dy dt. So the goal is to find out what's dy dt. So what formula are we using here? Pythagorean theorem, so you have x squared plus y squared equals c squared. I'm just going to call it 15 because I know it's always 15. That's never going to change. So why even bother with a variable letter thing? Just let it be 15. And what do we do with that? Find the derivative. What's the derivative? So x dx dt, so then 2y dt equals 0. And we know one more piece of information that I didn't write down. What else do we know? X is 10 right now. So x isn't always 10, but it's 10 right now. So we know dx dt, we know x right now. What do we need to find out before we can solve for dy dt? All right, we got to find out y. So for that, you go back to the original equation. So you're going to eventually need to work in your derivative, but if there's a piece of information you're missing, like, hey, we have everything we need except y, come over here, find out y, and then you can solve dy dt over here. Does anybody have an answer yet for dy dt? 11.18?
Oh, what is dy
Yeah. So y, sorry. So y is 11.18. Is this in feet? And so then dy dt is negative 4.47, and that's feet per second, I believe. Any questions with getting either the y or the dy dt? Why is it negative? Because tell me about dy dt. What direction are you going? Going down, and therefore what's happening with the y value? It's decreasing. So because you're going down, y is decreasing, and therefore dy dt ought to be negative. If you forget the negative and you say, well, I just want to know how fast, dy dt is negative, but the speed at which you're falling is 4.47. So the answer to the technical question is positive. That doesn't really matter. We don't have a negative there, even though dy dt itself is a negative. Any other comments, questions here? All right. Look at the next one about your magic rectangle. So they work on these magic rectangles that we're all addicted to, and they make it so that they can increase in size and go from like a phone to a tablet to a TV. Scroll, yeah, sure. So just imagine what the future holds for these addictive little rectangles. Just one device to do all the things for you. Take your phone in your pocket. At home, it's a TV for you. It's awesome. Your magic rectangle at work, getting more magical every day. Yes. What about capitalism? Probably. That's a good point. Capitalism preventing. But with competition, which is supposed to be a major feature of capitalism, people are going to say, well, you know, I bet I could make a load of money if I did this and sold it, and I could put all these other competitors out of business. So, unless you have like a full-blown monopoly that conquers everything, like Apple wants to do. Then, yeah. Who knew that today you'd get both like med careers and economics rolled into your related rate stuff? What?
I'm taking economics. Yeah.
Yeah, we have economics.
I know, I didn't take that class. On purpose. I got rostered for it. I will take any of the business schools.
I mean, I just took a class like that. Oh, no, I didn't take it.
Yeah, like finance, yeah, and except for accounting, because I don't like. Yeah. It does.
He has strong opinions, so he also has strong opinions.
Yeah.
One for everybody else. She'll say she's not honest. So, and she's, so she and her and she'll come talk to me about it, and I'll say, well, surprise. Yeah. Yep. So, celebrate, and then we're use A equals that to find the so that's a vector equation, right? So no DAT, look at it. It's fine. Like you're going to use this thing.
What?
So you'll have A instead of A equals BH. You'll say A equals 2H squared.
Oh, okay.
And then that'll be the
Oh.
Two or three or seven, whatever makes sense. I would prefer not seven. That's going to annoy me. But if you want your little revenge, that's what you get. Alright, we're going to pretend that's a rectangle.
Well, it's right.
So you have base and height, and area equals base times height, and then what do we know? Area is 64. What else do we know? So we know the ADT is 5.
B equals 2H.
And you know what? Base equals 2 times the height. So base equals 2.
Height is 2 times the base.
Height equals 2 times the base. Wait.
Yeah, 2 times the base.
Height is 2 times, yeah, okay. So the height is 2 times the base. The height is 2 times the base. So h equals 2b. Oops. All right, so height equals, that definitely makes things more complicated if you did it backwards. So make sure your reading part of your brain is turned off tomorrow. So height is h equals 2 times the base. So go back to your formula and rewrite it. How? B times 2b, right? So instead of base times height, you're going to eliminate one of those variables by doing this substitution. Say, hey, I know that the height is always 2 times the base, so you eliminate height, replace that with 2b, and then area, clean this up a little bit, area equals what? 2b squared. And then that's the formula you're going to use the rest of the way. So this is a geometric formula problem where you use a relationship between two of the dimensions to eliminate one of them in your formula. And then from there, it makes everything a lot easier because now you don't have to do product rule. You can just do your basic normal differentiation with the dt stuff. So get the derivative now, and what do you get from the derivative equation? 4b dv dt. All right, so just differentiate. You don't need product rule now because you eliminated the h variable by turning it into 2b instead. And using d dt equals 4b, slap the dv dt on that. What are we trying to find out? dv dt? So the goal is dv dt, correct? Before we can find that, what do we need to find first? B. So now that you have the main equation and the derivative equation, the goal is dv dt. You need to find out B first. So come over here, find out B, and then you can find out what dv dt is. Where did I put my answer? So now that you've got your main equation and your derivative equation, before you can get this, you first need to find out what B is. You know what dA dt is.
Oh.
The goal is dB dt. You need B. You find that over here using your A value.
Is it small
Yes, it is a small number. So dB dt is a less than 1 decimal. No, it is not.
0.221.
Yes. I think you might have forgotten the 2 as part of your area equation. Maybe. I don't know. Yes. Yes, sir. Oh, the next one. That is. Alright, so the next one is. You got that one. Multiply by 60 at some point. Oh, it was first. Never mind. Divide by all right, so getting B, what was your B value? Your B value. 5.66. Any questions with coming up with B? Then once you got B, what? You did this, right? So you have A.
Oh, okay.
Did you put 5 here for A instead of 64? Okay. And then you divide by 2. And then you square root. Okay. And then once you got that, over here, and you have 5 equals 4 times 5.66 times dB dt. And what do you guys get for dB dt? It's 0.22. That's what, feet per minute? All right, yeah, I have feet per second because I couldn't read, so, oops. Any questions with 4? All right, number 6, I believe, is similar, but before we get to that, I want to give you guys time to do an angle problem. So let's look at our balloon, because everybody loves a balloon. So you have your balloon. No, you don't. somebody else has your balloon, and then they're standing 20 feet away, and they say, aha, and your balloon goes up. Too bad, you'll never see it again. So you watch your balloon float up and off to the distance. To keep things simple, we'll just have the balloon go straight up. So it's a perfectly windless day, and the Earth has stopped rotating, and there's nothing happening except the balloon going straight up. So find the rate of change of the angle of elevation as you watch it with tears in your eyes. Yes, I am recording this, George. That's why I'm waxing poetic about this balloon.
Something a third grader would write.
I don't want anyone to complain that the language I'm using is too difficult.
You are on the ground.
Okay, shut up and do it, okay? Trying to channel my inner Ernest Hemingway. He was very much of a minimalist in terms of how he wrote. So. Just for that, every problem tomorrow is going to be a whole book.
That's just painful. Use that.
Yeah, I'm not actually going to do that. I've already run out of time.
Hold on. Which one is the angle?
The angle of elevation.
Yeah.
So
Is it the balloon?
you looking up.
Oh.
So
From the ground.
from the ground looking up. So between the ground and the diagonal, the
The
angle.
corner one is bottom.
Yeah, the bottom corner.
Yeah.
That's not 90 degrees.
You are 22 where it's rising. Oh, the balloon is wow. Why is he sad? Oh, because he wants to balloon is flying away. Oh, he's crying. Why is another person? Oh, because he's the one who left his balloon. Good eye. That's not nice. The balloon with the face. Oh, why is the balloon sad now? No.
He misses his person.
Yeah, he's never back.
Maybe a dolphin will find him, though, my friends.
Later.
Do you think you could draw a picture for yourself of this sort of thing? Yeah, I mean, that's like probably the most important part here. With this information, what trig function do you want to use?
What are we
So what do we have? So we have the distance, right? That's 20. We have something about the height. We don't know what the height is, but we know the speed at which it's rising.
Oh, the height is 50.
Oh, we have the height?
Yeah.
Oh, how about that? Y is 16. So we have the height, we have the base, so that's going to be tangent, right? Because that's the opposite over the adjacent side. You don't have anything about the hypotenuse, and we don't care. So we're using tangent here. So what would the equation then be? Tangent of theta, good, equals So think about what's variables and what's not. So the y is 15. Is it always 15?
No.
No. So the y is a variable. The base x, is that changing?
No.
No, that's always 20. You're just standing still. You're having a little temper tantrum without the balloon. You're not moving. And the balloon's only going straight up. So the 20 is fixed. That doesn't change. So what you need to be clear on, what quantities are changing, what sides of the triangle is moving, and what's not. If it's changing, that's a variable. If it's not changing, just let it be the number. And it's just a constant. So then that's your equation that you're working with. And you have to differentiate this so that you have main equation and its derivative. What's the derivative of that tangent equation? Sorry. So secant squared theta, that's the derivative for tangent. Now don't forget something important. d theta dt. And if you forget, just remember, oh, the goal is the rate of change of the angle. So I need d theta dt because that's what I'm looking for. Over here, what's the derivative of y/20ths? Yeah, it's 1 over 20 times dy dt. So, because the y is in the numerator, not the denominator, you can just kind of treat the 1 over 20 as a coefficient, and like y becomes dy dt times the coefficient 120. So let me write that over here, so we have them side by side instead. And then before we can solve for d theta dt, what do we need to find out first? What theta is. So you know y, you know dy dt, you don't know theta. So you got to find out theta before you can solve d theta dt. So you find out theta over here. Once again, we're working the main equation, finding a piece of information, and then bringing that over here to the derivative to solve. So now you can plug in 15 for your y, find out what your theta is. So what's your angle? 0.64. So if you're in radians, that's 0.64. If you're in degrees, it's something else. I don't know. It doesn't really matter. Once you have that, whatever it is, radians or degrees, you plug it in over here. Now, who doesn't like secant? Be honest. All your hands should be up. Let's be real. Nobody likes secant. So what's the reciprocal of secant? Cosine. You could divide by secant, but that would be dumb. You could instead multiply by the reciprocal of secant to get d theta dt by itself. And the reciprocal of secant is cosine, so bring this thing over here, multiply it over, call it cosine now, and then plug in your numbers. So you have cosine squared of theta, now you know what theta is, times 1 over 20 times dy dt. And you know that theta is 0.64. So I would do cosine of 0.64, see what that is, then square it, and then divide by 20 and times by 2. So, like order of operations on the calculator, cosine of 0.64, answer. Answer squared, divided by 20, times 2. And that'll give you your result. And what does that end up being? 0.064? Cool. I'm only just now noticing that that's like exactly 1/10 of your angle. And units are radians per second. All right. So that's a pretty good review. We didn't cover all of our bases, but we certainly covered most. The only other thing I really wanted us to look at was one of those distance formula problems. The spherical ball being inflated. That's a typo. It should be deflated if the radius is decreasing. Sorry. So the spherical ball there is actually another rectangle problem, but with a sphere. In terms of how you do it. So like, there's going to be it's just another geometric formula problem. Here you have this geometry formula, take its derivative, and then there's some interplay where you have to find some piece of information in the original equation, and then take that and plug it into the derivative. So that's what 6 was, that we didn't get to. And then you've got your distance problem there at the end for number 7, if you want to look at that. dVdt will be... So V is 1,000. And then R is 6.2. Plugs in the derivative. Del dRdt.
Where'd you get -5?
Because you're deflating the balloon.
Oh, I guess
Or the
I never
ball.
put that in there.
Okay.
Because
And it
we
should say
multiply 4,000 or this number. Or 400.
Would you like me to post my key to these problems on Schoology? All right, so later today before I go home, I will scan these and post them along with the problems themselves.
2,407.
Yep, 2417, 2418. Just a rounding error, so that's good.
No, it's not a rounding error. I forgot to. Well, after this it is, but I forgot to put the -5.
I mean, you forgot the -5, but once you had that, then it was just a rounding error. All right, do we have bells today or no?
It should be. It should.
But there's AP Chem happening, so maybe not.
Oh, okay.
Ding! See ya. Yes. I think the quiz is going to be pretty similar to this.
Oh.
Maybe somewhat different numbers, different formulas, different scenarios, but very similar in terms of difficulty level.
So, and this is not, is this going to be like on the test or no?
That's way harder than what's on the test.
No, but like this kind of question then. That doesn't count as a ladder, right?
That,
I don't know.
yeah, that's a ladder problem.
Oh, that is. Okay.
Yeah, it's a variation on a ladder problem. It's not really, because with a ladder, when this goes down, that goes out.
Okay,
Here, they're both coming towards each other, but it's a Pythagorean theorem problem.
gotcha. All right, I'm good with those.
Yes.